Hi, everyone. Thank you for attending this amazing session on tokens, and mainly on the account recovery layer that I'm going to be covering today. So my name is Viola Lykova. I am a senior software engineer with an SRE mind, and I am a person to go person when it comes to authentication. I own end-to-end authentication flows, and I'm very passionate about making sure that your authentication does what it's supposed to do. So let's talk about the hardening of your login. The bad stuff that happens, it happens with the worst paths in your system. The worst paths are not the paths that you harden so much that they look perfect. This door is actually representing the way that your login might look. It's very secure. It's not prone to any attacks. I would hardly believe that any hacker would be able to go through the login page. However, you might not be thinking about the backdoor, and the backdoor in this sense is when the attacker chooses to go for the easier path. And the easier path is typically where you're restoring access to your system, the reset password paths, and paths that you use to create the new trust with the system. So you establish who will be now in charge of the system. And typically, this has been treated as a UX. It's not a UX when you are hardening something that can re-grant access and reissue tokens that would be able to grant access to the system where the user originally had it for. And I'll show you the demo of how exactly it can damage the account and how attacker can still be logged in if they have the access. So I know that multi-factor authentication is now the standard. We all know that single sign-on and passkeys, we keep polishing those things. We keep making login path we'll keep perfecting it. And we will be probably perfecting it still, even after my talk. But obviously, the path that goes behind, it's not been hardened. It's probably been done years ago and then not really revisited because everyone just treats it as a back path. And when we imagine a hacker getting into our system, we typically imagine a person who comes to our website, for some reason goes to the login page, and on the login page tries to just brute force until it works. Yes, brute forcing can be effective, but that's not the easiest way around your system. So I'm going to be talking about the failure modes that I think that are most important when it comes to recovery and when it comes to the actual session handover to attacker. So this is what I call a really poor authentication reset flows. This is where you say, basically, this is my login path. It's amazing. But when you reset when you reset access to your system, please close the gate. Unless you want an attacker to go in. But there are other ways to go in. So why would you just tell anything to the attacker? They will always choose the path that is easier and the low-hanging fruit rather than going straight through your login page. So the password reset is basically not just some kind of a flow which will reissue the token and it will just go back to normal. Things like you will still be signed on different devices can happen. When it happens, then it means that whoever was already in the session and whoever was already resetting that password was still in the session and they will keep in the session. So multi-factor reset, same thing. We can trust, we can reissue trust, but the problem is that we won't really have to think about other ways of logging in through the login page rather than just stay in the system using the multi-factor authentication device. And the lifecycle management is quite poor in that sense because, yes, if you think about it, you have other means that allow you to authenticate in your system and allow you to be in the system and reissue the trust. But what if someone has the access to that device or the access to that means of authentication and it will actually let them into your system, by default, and you will be also in the system. Might not be already, but the problem is that the lifecycle management, we need to think about it as a chain rather than just single point of entry. So the support recovery can become a lower assurance bypass. Yes, this is true, because the assurance that we are giving the system that we are managing is important at the level that we need to look at the chain and where the weakest paths links are. And if we don't treat those weakest links are, like reset password, reset token, whatever, we then are opening access to those being the low-hanging fruit that I'm talking about. So this is the recovery chain diagram. This is how you essentially request the access to be restored, to be back to your hands. And this is a PDF checklist that you can download from our website. It basically lists everything you need that will help you essentially harden your reset flow. And I bet so many companies still have the old UX and just the path that actually just restores the token but is very weak, because the login will probably be quite nice. So how does this chain particularly happen? So it starts with a request for a reset. Let's take the easiest part, the reset password. Then it happens the delivery of the message. So someone gets the message. Who gets the message? It's a good question, because it can either be an attacker who has some bad thoughts and maybe intentions to your account if you are, well, if it's a bank account and you're very rich and they just want to get a hold of the money, they will get the notification to their email, and they can actually change the notifications to actually be delivered to their email accounts rather than yours, which was the original one. Because once the trust has been reissued in the account, they are now in charge of that account, and you can do nothing, essentially. You'll be locked out. Well, I mean, you probably are all familiar with the verification. Of course, you would click the link, it will lead somewhere. But what if the token in that link is actually not being reissued? What if it's replayable? What if you can actually use it more and more and more? And it's not going to expire. There is no time to leave. There is nothing that is set on this token to be secure. And I mean, yes, you can always say, okay, I have the time to leave on the token. It's now very secure because it expires after one use. We make sure to expire it all the time. But then what if the token has other things? Like, for example, on your website, what if your session is actually showing the times when something is happening? So clock skew or the difference in timing on delivery of the notifications. What if your UX is actually the bad guy and is telling your attacker who's trying to get in your system, they are essentially getting the messages from your system like that password doesn't exist in the system or that login doesn't exist in the system. This kind of stuff can actually damage the chain at this point of verification, because it basically tells them where to go and look for it. And the UX is actually quite an important part at this point, because if you think about it, when you look at the times, which messages are delivered at what time, and what kind of text do you see when the request submits, what happens after that. When you look at those timings and compare them, the verification becomes quite a vulnerable path, because, well, we can actually understand based on that timing what is exactly happening with the account. We can also try and use different emails of, for example, the person we know would definitely have the account with the system versus the person who would definitely not have, or like a fake email. So these things can happen at that point in the chain, and we should never think that it's just that verification point. We should think that this is a problem of multiple factors in the chain. So then will come the change. The change is it's a factor change. It's a credential change. So we can change the password. We can change the primary means of accessing of the account, like a phone number, like the account change, not necessarily the security event. But still, this can be changed and then locked out of the original account holder. So then comes the session shutdown. Not many systems are actually shutting down the systems when they reset the password or reissue some token, or even when the multi-factor authentication device allows you to actually use different codes at different times after the expiry, or when a SMS message arrives and you allow to use the older message still. This is the kind of stuff I'm talking about. Then notification. So notification, as I've mentioned, it can happen to both sides. So it can happen to the original user who has issued the claim to reset or re-grant the access, reissue the trust. Or it can also happen with the attacker. They can simply change at the point of change. They can happen to change the email or the primary means of receiving that notification. And now they will be notified, but the original user won't be notified. So, and obviously monitor. As a site reliability engineer, I feel like observability is one of the things that you need to always think about. So alerting yourselves and looking at the spikes of the particularly high attempts to log into a particular account or from a particular IP address. You need to be observing, you need to be monitoring this stuff. And I think if you're not doing that, you're more prone to actually get hacked. And yeah, I mean, let's go to the next one. So these are some failure modes that I feel like the most important ones. There are many of the failure modes, and honestly, every day, I feel like attackers will come up with more and more, but it doesn't mean that we should be covering everything at once. I think there are the core failure modes that you can actually talk about that will serve as the core understanding of just how easy it is to get into the account. So the first class is the signaling in user enumeration. I'm sure everyone is familiar with the typical simple user enumeration that happens when an attacker simply wants to request and see what kind of users are in the account, are in the database, what kind of emails are not in the database. And it's not just going to happen through like different text, right? They can observe, attackers can observe different things that happen to that account. So the response wording can be different at particular operations. So they input something and they monitor what is happening at particular input. The response times, as I said, if there is a small discrepancy, even like by a couple of milliseconds, and you actually notice that, and typically people who want to really badly get into their account, they do notice that. It is becoming very obvious that the account might exist or the account might not exist, so they shouldn't waste the time on it. The email sending behavior, whether you send an email straight after and you allow the fastest recovery time and reissuing the trust, or is it gonna wait for a second and then still give away some details? And obviously the rate limiting differences. So when you're rate limiting for particular operations, like for example, you're brute forcing passwords or brute forcing emails, say that you're rate limiting them in different ways. And that is a discrepancy that we will be looking at if we wanted to hack into that account. So status codes, different status codes. Developers honestly like to use different codes. I don't know why. Well, no, I know why, because they want to look smarter. But honestly speaking, using different header codes, it's probably going to be just a more giving of on the side of the information of the account, and that is probably not what you want in your system if you want to be secure. You need to stay as generic as possible whenever possible, because generic is good. Generic means that you are not giving away any details. You're not supposed to be communicating with the outer world unless the person exactly exists and it's the trust that we want to issue. We should not communicate any changes, any information to the outer world with our system. And obviously the UI state. The UI is quite progressive at this point in time. We are looking at masterpieces in terms of UI, and yet the messages that we see, like this email does not exist, it basically means that you're saying, okay, this doesn't exist, right, we're gonna cross that out from the database. Let's try another one, and say rate limiting on the emails is a bit different from the actual emails that exist. And now we're talking. So, and obviously the API response shapes. Maybe as developers we use one type of shape and template for the JSON response that comes through when the account doesn't exist. Maybe we even say that account doesn't exist in the message of the JSON, or do some kind of a coded message. And then we do a different thing when a separate API response comes through. So I think that here probably the oracle will be in details and smaller details that we want to make sure we don't give away, and we don't want to let the accounts to signal the things that we did not intend it to signal. So the failure class 2 would be concerning with the token lifecycle and replay. And I've already mentioned that, but it's worth talking about it in a deeper sense. So this is a typical simplified, super simplified path of the lifecycle of the token. So you can see that we can create the token, it will then be active until something happens to it. It can become suspended at some point, it can also become deleted. So this is a very simple example of how you can manage the token. But there are more complex cases where you'd probably have different states based on different operations, based on different environments and states. And that is when it becomes very important to make sure that you expire tokens in the life cycle when they're supposed to be expired. So whenever I start with designing the architecture for the authentication flows, I actually start with the paths that recover the accounts. So I start with the backend shape and specifically the token life cycles, because I need to understand what exactly will happen at each point of time in the chain when the person is going to be restoring the access. What kind of cases do I want to avoid, and what kind of cases I want to actually support? So we should ask questions like who this token is for, what action is permitted to perform with this token. And again, this comes to the point where when I work with AI systems, what action should be performed with a specific token is an interesting question, because if you think that you can issue just one token for all of the actions and just grant access to the AI model on an MCP server that would just allow all the operations, then you probably should think twice, because it can actually act on your behalf with that token. And especially if you don't expire it, that is going to be a really big mess, because it can grant things to, well, essentially any application that might be on their radar. How long the token is for. So the time to live of the token needs to be set explicitly, and it should be very temporary. 15 minutes, 30 minutes, depending on the system, but you have to make sure that the token expires. It needs to expire, because the token is existent in that system for the purpose of recovering an account. The recovery of the account is an action that you undertake in a specific period of time. So you don't want to be recovering your account in the course of a week, in the course of a month, or a year. You want to simply do that action in order to access your account soon enough after it. So when you expire the token, this becomes, when you don't expire the token, this becomes a severe vulnerability, because this means that this token is active somewhere on the internet. I will be able to pull it easily with a model in maybe 5 minutes from across the internet, all the active tokens, and just see if, check if it works and what system it belongs to. So yeah, first use only. First use only is basically the token that goes only once, and you then expire it after it. So you do not allow to reset the account access to someone who has already used that token or used that link. You need to reissue the same token again. And it's not going to be the same token, it's going to be a different token this time. So, and obviously, yes, the mechanism that invalidates the token is very important as well, because we need to think about how exactly we will invalidate the token, and will it be secure enough that it's not going to be actually alive after we invalidate it. So yeah, I think this is pretty aggressive, but it's very, very needed in the systems, because if we avoid the tokens to be quite broad and quite permitting, then we will let the system be more secure. And I think the most secure stuff starts with the tokens as well. So failure class 3 is the leaking of the URLs. Oh yeah, this is the one that is basically when you have a URL and you create, you generate a token and you then include that token in the URL. So you want to make sure that your exact token is not leaking through that. For example, I see in some systems, for example, we have logs, right? Like Datadog or Grafana. And then we log what happens on the system, which is great. But then I see how that URL that is logging what is happening on the website is actually showing the exact token that is used to authorize the person. And knowing how, the logs can be stolen, the systems can be hacked, this is not a really secure way of storing the session URLs. And the leaking of the token through the URL is quite an often, well, I see it a lot in the systems, and this is bad because analytics, yes, they are good, but they can bring a lot of damage if you store very sensitive data in the in the non-permitted space where it's not going to be the main destination of that token. So you shouldn't be storing what is not supposed to be there. So yes, and analytics, I think it's quite often that happens that you will basically just store wrong data for whatever purposes, but it just accidentally happens to be there. So yes, strong token, weak plumbing, and the same incident happens over and over again. The plumbing, when something breaks in our house, the plumbing, for example, right? So we know that there's probably not one point of failure. We know how it could be just bad across a couple of different stages. So the same can happen with that URL. It can basically travel from one point to another point to then go and end up in a completely different point, but then end up in the hands of sysadmin or a person who will forget to use the password on their laptop, and then the open link is on their screen. So you can easily access that, use it, and that kind of plumbing is bad for the system. And if you want to actually have like a system that is secure, you would probably need to think about securing the surrounding area of those things that you are working on. So if you're working on tokens, make sure that you're creating the safe area for that token and the life cycle that is within a secure environment that will be contained and not going to be let out to live wherever it will want to. So I would probably name a couple of the leakage paths that I can think of here. So browser history. All of us know that in the browser history we persist things. That is a leak. That's why I always say delete your browser history, because the browser history can actually possess the risk for the weaker configured websites, and you can actually risk with the tokens. The link scanners that will scan across the internet, and that can potentially leak. And that's why if you don't expire your token, that's where it would probably become the best liability in those scanners, where we are pulling a lot of aggregation into one place. And unsafe link generation, when we initially generate the link the wrong way, put stuff that is not supposed to be in the link. So in the URL, we have a lot of things that are not supposed to be there. So yeah, and email previews, actually. Email previews are quite a thing, because when you look in the email, you can see the link, then you don't delete that email. This is a leak at this point. So failure 4 would be the multi-factor reset, email change, and the weaker alternative channels. This is an important one. So even though multi-factor authentication is quite an advanced technology that is used everywhere right now, for authentication is great, But the problem is that every single time that you are configuring an authenticator to actually take the access to, well, the responsibility of reissuing the trust for your system, you're actually creating a security event. Security event in the sense that when we are creating the link of a third-party authentication application with your system, we're actually granting that third-party system the access to your system and reissuing that trust. So we would then be able to access anything. And then also it comes to the point when we want to change something in the account and we want to control it. It will be so easy if we can just have that multi-factor authentication set and access to that authenticator device. Not even device, they're actually now plugins and browser extensions, so you can easily generate those codes. Once you have the account, especially if it's a cloud-based account, then you can easily overtake any session. So in this sense, I would say if you want to create some kind of a link to any third-party authentication, you need to think of the fallback paths that will actually allow you to be more secure. And if you do not do that, then the paths that you are not supporting would become the weakest links in your authentication. Therefore, when you go to the login page, it's absolutely secure. It's great. You can be the top leader of the login page, but then your support paths that can be easily found, well, like the fallbacks that you're creating for authentication, like multi-factor authentication, then the weaker channels will be the giveaway that your system is not really secure. So the mistake that I see teams are making is resetting the sessions without the actual shutdown of all of the other sessions. I believe that you shouldn't really give the user the choice of resetting the session, and you should always shut down the sessions, because think about the way where you are authentication on different devices. What if one of the devices gets stolen? You need to, by default, let the system reset the password and reset exactly all the sessions that are open. It's not going to be a choice, but I keep seeing that it's a really good, like it's a choice still on the systems, which is, it's an option for advanced users who understand that the implications can be serious when you don't remember that maybe a phone that was stolen like maybe 2 months ago from you actually has an active session that can be still accessed. And this is really bad when you have that, especially on the bank accounts or some other important sensitive information applications. So I always say that the password changed is not the account recovered, because we don't know what happens within that process of changing of the password. The password can change, but the account might still be, well, being used by different actors. So you as a primary actor and maybe other ones who are attackers, who are intercepting your sessions, maybe some connected devices, maybe the APIs that you've granted access at some point. So those accesses, they would still be present. And I'm going to show you the demo that basically shows that. So let's just look at the demo here. So what's happening is basically I have provided a bit of a what is going on. We're going to see that in a sec. Let me just let's put it on the bigger screen. So this is a dashboard. We can see that this is there's just been a login and the session was created for one user. We now go to the attacker session. We're now in the attacker's browser and we've just logged in. These are the open sessions. Then we go back to our normal browser, the victim's browser. We reset the password. This is a really good message. If the account exists, then we'll send the email. This is a typical link to just restore access. Now we go back to, we copy the link, we paste the link in, and we go back to reset the password. We input the new password, and notice that we're using the token. There needs to be reset after that. Now we can re-log into that session, So we, as a victim, think that we have just re-logged in. But in the active sessions, and we actually see that it's not been revoked. I hope I go to the session here. Yeah, so the sessions are not revoked. So you can still pretty much see in this browser, this is the attacker browser, that it's still active. All of the 3 sessions are active. The previous session of the victim browser, the attacker browser, plus the new, with the new password reissued. So this is the kind of trust, and I'm reloading the page, and it's not going to get anywhere. So we're still logged in all the devices that we were logged in on. This is scary because imagine if you've logged in your bank account on a computer that was somewhere in the house. Then someone comes, steals that computer, and then accesses the session that is still going to be present. Or if someone accesses your account without your knowledge, and they will still be there pretty much. So let's go to the next demo. This is the fixed flow. This is where our recovery artifact burns after the use. So this is important to just notice the difference. So we still log in. We get our session ID. We go to the sessions. This is our active session as a victim browser, which is great. We want to forget the password. Now we can see in the attacker browser we've just logged in. Both sessions are active. So in our victim browser, we're now going to be resetting the password. We're going to again provide our email, get our recovery link, paste that in. The token is there. New password. Great, we've updated the password. Now we're using the new password. And we can see that the sessions have been revoked. There is a timestamp staying there. So we only have 1 active session at this point. We don't have any more. So the attacker's browser, on the reload of the page, will log out, and they will not be able to log in with the same password. So this is the kind of stuff I'm talking about. We need to be more precise with the things that we are doing in our systems. We need to make sure that whatever is going on with our trust reissuance, it's actually worth it. It's actually making sense, and we notify the actors that are in that loop of the recovery. And recovery paths needs to be probably the first path that you will create, rather than restoring and redoing your login to make beautiful and adhering to standards. Create the good reset flow to make your session secure, to make your users safe. And this is the first thing I would start to do if I was developing another authentication path. So this is the shutdown sequence that we want to see in production. Like, this is the correct stuff that we want to actually have. It starts with burning the artifacts. As I said, first thing that we have created in that demo, we're actually burning the artifact that was already used. So the token that we used to restore the access with, the token that was before issued to keep the session in. We want to also revoke the sessions. And as I said, this is probably one of the most important ones. In fact, it's not probably, it's definitely one of the most important ones. We need to revoke the sessions and make sure that whoever already had the account access will no longer have so. Because we've just changed the trust. We've reissued that again. So we need to rotate the tokens. We can't use the same token all the time. We need to rotate them and make sure we're using different tokens for different operations with different access grants and with different flows. And then also require reauth at some point. So I know it's very convenient to have the session always on. We could have the session, in fact, all the time. You know, some systems do it, but I really like what the banks do with the sessions. You keep kicking people out of the session to once again show that they are who they are. And this is the important stuff that we need to do for all the systems, whatever it is. If it's a shopping system where you have your address information, or if it's a some kind of a game account where you probably have your great trophies or whatever, the amount of hours you've played. This is all requiring that re-authentication once a life cycle happens. So, and in fact, one of the systems that are doing it quite great is NPM. So, for example, the Node Package Manager is a manager of the packages for your Node applications. And it basically allows you to create a token that allows you to be the creator of the account and to authenticate with that token. But that token can expire in a year, in 6 months, in 2 months, in 1 month, or every week. And that is a good way, it's a good strategy to manage the secure tokens and the life cycle of them, because it allows you to still prove that you are who you are. Yeah, and then notification of the user. Obviously, when I showed the demos, there was the email that came to the inbox of the user who was restoring the account. And that inbox can change easily. If someone has access to your account already, someone wants to get change the means of logging into that account, they can absolutely change your email. And if they do, then you will not be notified. So again, we need to make sure that we notify the user when we have changed something. So the original user needs to get the message as well as the new email holder, so that we know that something go wrong. When something go wrong, we basically know about that. And yes, signal whatever is happening. Every event needs to be signaled, needs to be recorded on the logs, but without sensitive information. So monitoring is, as I said, one of the key things here in this bus. If you don't see what is happening in your system, you cannot improve it. If you don't see how your tokens are operating at the moment, especially if you're in charge of a legacy system, you cannot improve it, and you cannot reissue them, you cannot manage the lifecycle properly. So the first thing you need to do is to inspect how exactly is and what is happening at each point in time when you reset your password, reset the credentials, reset anything within your system that is the backside of the login. So you need to make sure that there is a continuity of the path that the user can follow along to then go back to the login and re-log in to get back to the application. And we need to support the fact that we have secrets, and storing secrets needs to happen securely on the server. We need to really think about how we can securely store the credentials without without letting anyone else to access them, even the people who are managing the system. So the investigation when something happens can actually be effective rather than being ineffective in the sense of seeing what is going on but not being able to help it. So there's a builder checklist that I have created for you to download. Feel free to follow that link. And it's not a malware. It's just a QR code for the PDF. So you can get all of these checkpoints that I created today for the talk, and you can actually use that on Monday to harden your authentication systems. If you're managing dashboards, if you're managing something that is involving that login path, then you can absolutely use that checklist to work on the scope and improve it. And all of these are actually also quite important. So I think that is all for today. And if you have questions, please do ask me anything to do with that authentication, resetting of the tokens. Thank you.